Aram, go ahead, take a look at the first question. They're saying the structure of one molecule of a compound is shown in figure 10. What is the molecular formula of the compound in figure 10? Go ahead, take a look at the structure. Let me know what you think the molecular formula is. Meanwhile, just give me 2 minutes. I'll come
Okay.
over in 1 second. Okay, Arham, I'm here.
MS at C3H6 D.
Yes, it's C3H6, correct. Okay, next question. Alkanes burn completely to produce carbon dioxide and water. Balance the equation for the complete combustion of butane gas. So either if you want, you can write on the screen, annotate on the screen and complete it, or you can say it out, whatever you prefer.
Okay. Miss done.
Yeah, Aram, go on. How do I balance it?
6 oxygen, like 6, okay, C4H8, 6O2,
Uh-huh.
then give rise to 4 CO2 and
Correct.
4 H2O.
And 4H2O, correct. That's balanced. Okay, next they're saying figure 14 shows some information about alkenes, ethene, and propene. Complete the table. The structure of propene must show all the covalent bonds. So you have to first over here tell me the molecular formula of the ethene, and then you have to draw the structure of propene. So
Okay.
either you can go ahead and again you have the option, you can write on the screen, annotate on the screen and draw it over here, or you can draw this the formula, you can tell me yours like verbally. For the
Okay.
structure, you can draw it on a piece of paper and send it to me, or you can draw it on the screen, whatever you find easier.
Okay. Miss, molecular formula for ethene is C2H4.
Correct, it's C2H4.
Okay. Miss, I think it's better if I draw it on paper because my writing won't be good from a
Yeah,
mouse.
yeah, and whatever you're comfortable with, no problem.
Miss, every alkene has one double bond, right? With carbon?
Yes, up for your standard, up to your level, alkenes only have one double bond. But speaking honestly, they can have multiple double bonds as well. But
Okay.
then the name has it. When we're naming it, we name it in such a way that we show that that there are two double bonds. For example, if there are two double bonds, so then we say diene, right? So diene means that there are two double bonds in it. So
Okay.
then that will be in the name. But so far up to your level, yes, you only have to worry about one single bond, one double bond.
Okay. Miss, because like I was like wondering if we cannot identify like by the name that if it has a double bond or a single bond. That's what
Uh,
is happening.
as long as it says ene, as long as it's an alkene, it has one double bond at least.
Okay.
As long as it has ene, it will have one double bond. One double bond minimum, right? Minimum, it will at least have one bond.
Okay. Miss,
So
I see.
you can make one double bond and you can make the rest of them single bonds. That's what you can do. All right. I'll just take a look at them. Okay, Arham, there's a problem with your structure. Your formula says C3H6, but when I count the hydrogen you've made,
Okay, it's
getting
8.
8 hydrogen. Problem number 1. Problem number 2. Remember this, that each carbon can only be bonded to 4 hydrogen. 4 can make 4 bonds maximum. So if I put a double bond over here, this carbon in the middle already has 2 bonds on the right side and 1 bond on the left side. It only can make one more bond because the maximum number of bonds a carbon can make is 4. Why? Because it only has 4 pair of electrons, 4 electrons in the outer shell. It is making a covalent bond, so it only has 4 electrons. So it can only make 4 covalent bonds. So 1, 2, 3, it has already made 3 bonds. So we can maximum put one more bond. That's it. Then on this carbon, the number 1 carbon, it already has 2 bonds. The maximum number is 4. So it can
Okay.
have 2 more hydrogen at the very most. This carbon at the very end, and this carbon has only 1 bond, so it can have 3 hydrogens. And now if you will count the number of carbons and the number of hydrogen, you will see you getting C3H6. 1, 2, 3, 4, 5, 6.
Yes,
Right?
madam.
Making sense?
Yes.
Okay. After that, figure 2 shows the molecule of dichloroethene. Ethene means that it's an alkene.
Yeah.
Chloro means that it has
That's chlorine.
chlorine atoms. Di means that there are 2
Two.
chlorine atoms. So one over here, one over here. Dichloroethene is produced from ethene and chlorine. Okay. So this is, we did this reaction when we studied the topic of alkenes. We did the reaction of alkenes with halogens. In the overall reaction, ethene reacts with chlorine and forms dichloroethene and hydrogen. Complete the balanced equation for the overall reaction.
Miss, can I write on the board?
Yeah, yeah, Aram, go ahead, go ahead.
To see. Miss, is this fine?
Arham, I can't see anything if you've written something.
Oh, 1 minute.
Yeah, now I can see it.
Okay, but
Okay, you have written, okay, let me just check. You have written that you're going to have, okay, Arham, 1 second. You have said 2Cl2. In this, over here, in this formula, C2H2, I already have Cl2.
oh,
So that makes your Cl2 4Cl2. So your balancing becomes incorrect.
okay.
So I'll tell you this, your equation is correct, as in your reactants and products are correct. You need to take a look at your balancing once more. If you want, I can tell you what the balancing is, or you can give
Mm,
it another try. So this over here is already Cl2. So when you put 2 over here, it becomes
Miss, can you,
this chlorine is...
Miss, can I change it?
Yeah, yeah,
No.
go ahead. No problem, madam. That's
Miss,
your...
is it possible if you can put like 4Cl2 on the product side? Won't that fix it?
4Cl2 on the product side, but when we react in ethene with chlorine, chlorine is not the product. I can't just add 4Cl2 by myself, right? It has to be part of the reaction.
Okay.
If you like, you can brainstorm it and figure it out, or I can tell you. You can let me know whatever you prefer.
Miss, then I'm not sure what the answer is.
No problem, Arham. First of all, let's first start by writing down the product. The final product is HCl. Now let's start balancing. I have 2 carbon on the reactant side and 2 carbon on the product side. So I'm okay with carbon. I have 4 hydrogen on the reactant side, right?
Okay.
And on the product side, I have 2 over here and 1 over here. So that becomes 3. So hydrogen is not balanced. I will have to balance my hydrogen. Okay. Over here, I have 4 hydrogen and over here, I have 3. What else is not balanced? Over here, I have 4 chlorine. Over
Yeah.
here, I have 2 chlorine, 2 from here and 1 from here, 3 chlorine. So I need to balance the hydrogen and the chlorine. The carbon is balanced. If the carbon is balanced, I'm not going to put anything over here because my carbon is already balanced. If I put any number next to my dichloroethene, I will have to put a number over here as well, right? Which is going to make, which we don't want to do. So I'm not going to put anything over here, which means I have to do the entire balancing simply by balancing HCl. So what can I do? I can put a 2 over here. If I put a 2 over here, now I have 4 hydrogen on this side and 2 from 2 here and 2 here. 4 hydrogen. 2 2s are 4. I have 4 chlorine and 2 from here and 2 from here.
Yeah.
4
Okay.
chlorine. So now it's balanced. So if I want to balance this equation, all I have to do is write down 2 HCl.
Okay.
All right. Next question, they are saying the structure of a molecule of ethene is shown in figure 8. Figure 9 shows the incomplete dot and cross diagram for a molecule of ethene. Complete figure 9 to show the electrons of C double bond C.
There's two dots and two crosses.
Yes, we will make two dots and two crosses, like so. So this one pair is one double bond and the second pair is the second bond. The incomplete combustion of ethene in air produces water as one of the products. Give the name of another product that forms due to incomplete combustion of ethene.
Carbon dioxide.
Incomplete combustion.
Okay. Carbon monoxide. Sorry.
Carbon monoxide. We can also get just carbon, like solid carbon, which is known in English, we call it soot, right? If you've ever seen that, wherever we're burning a lot of
We were
fire.
discussing it, I think, in previous term, in
Yeah,
grade 8. I
yes,
mean, grade
yes.
9.
In previous, exactly. In previous turn, you must have studied, you and I also studied that so it can either be carbon monoxide, and carbon is also correct. And if you say soot, that is also fine, but carbon monoxide and carbon. Okay. Then, okay. Molecular formula, forget it. Forms of polymer, we are not done polymer yet, so we are not going to do polymer. Polyethylene. So related to energy change. Okay. Substance X is an unsaturated hydrocarbon. The structure of a molecule of substance X is shown in figure 10. Explain how the structure of substance X shows that it is an unsaturated hydrocarbon.
Miss, because we can break the double carbon bonds to add more hydrogens or other substances.
Right, right. You can just say that we have the presence of carbon double bond, right? Or we have the presence of a double bond between the carbon atoms. That is
Okay.
a good enough answer. You don't have to add anything to it. Okay.
Okay.
Two liquid hydrocarbons A and B were tested with bromine water. One hydrocarbon was known to be an alkane, the other hydrocarbon was known to be an alkene. Each hydrocarbon was shaken with a few drops of bromine water. The results of the test are given. Explain these results.
Means hydrocarbon A will be an alkene because an alkene tends from orange to colorless. On the other hand, hydrocarbon
Mm-hmm.
B will is a alkene because
Yes.
alkene doesn't change color.
Yes. So the reason your alkane doesn't change color is because alkanes are non-reactive, right? Since it is an alkane, it does not. It has a single covalent bond, which is hard to break. So it does not react with the bromine in natural light. It has to be UV light for the reaction to take place. On
So
the
miss,
other hand,
alkanes are saturated hydrocarbons?
yes, alkanes are saturated hydrocarbons.
Okay.
And your the alkene, on the other hand, since it has a double covalent bond, so we can break one of the covalent bonds to undergo an addition reaction and we can add bromine atoms to it. So
Yeah.
the color changes. But we can't do that with alkane because alkane only has single covalent bonds and we cannot break them easily at all. Butene reacts with steam to produce butanol. Which type of reaction takes place between butene and steam?
Addition reaction.
Yes. Okay, we're not worrying about the chloropolymer yet. Okay, alkenes and alkanes are hydrocarbons. The structure of a molecule of butane is shown. Which of the following is the empirical formula for butane?
Miss, what is empirical formula? Is it the simplest ratio?
Yes, the simplest ratio between the atoms in a molecule.
Is it C4H10?
Um, no.
C.
Yes, C2H5. It's the simplest
Miss,
ratio.
miss, because
C4H10
it's
is the, yeah,
divisible
it's
by
the
2.
molecular formula. So you can simplify it to C2H5. Figure 14 shows the structure of a molecule of hydrocarbon Z. Give the name of hydrocarbon Z shown in figure 14.
Butene.
Butene. Complete the balanced equation for the reaction of hydrocarbon Z with bromine.
Miss, bromine gas, right?
What is the state of bromine at room temperature?
Gas?
Are you
No,
sure?
liquid. It's a liquid.
Yes, it's liquid. Exactly. So liquid.
So it will be just be Br, not Bi2.
Yeah. It will be Br2. Even if it's a liquid, the formula will be the same, Br2. The formula doesn't change. Okay, the formula of the
Okay.
compound does not change just because I'm changing its state.
Okay. Miss C4H8 Br. Wait.
Sorry, Aram, what did you say?
No, that's nothing. Wait.
Okay, no problem. Take your time.
Miss C4H8Br2.
Yeah,
C4H8Br2 and
okay,
B2.
hold on. 1 second. I'm writing it down. You are saying C4H8Br2 will be the product.
And Br2 will be reactant.
Right. That is correct. Okay. Now, after that, they are saying basically, um, this is too easy. The molecules of three organic compounds A, B, and C are shown. A small volume of bromine water is added to each of the substances A, B, and C, and the mixture is shaken. Explain why A and B decolorize bromine, but C does not.
Miss, because substances A and B contain a double carbon bond, which can be
Mm-hmm.
broken to add bromine, but substance
Yes.
C cannot. None of the bonds can be broken to add a bromine molecule.
Okay. The answer is fine, but you need to use specific terminology, right? So the terminology we're going to use is this, that substance A and B are alkenes and they have a double covalent bond which allows them to react with bromine. Substance C is a saturated hydrocarbon or it's an alkane and it does not have any double bonds, hence it will not decolorize bromine. So you
Okay.
want to talk more about double bonds, the bond breaking and the addition reaction and all that. That's more for me to
Okay. So, Miss, can we refer
explain to
to
you.
like A and
Okay,
B are
ethane is a, yeah. Sorry, here you go.
Miss, is it possible if we can refer to substance A and B as unsaturated hydrocarbon and
Yes,
substance C as
yes,
saturated?
yes. That would be
Okay.
completely correct. Ethane is a hydrocarbon raw molecule of ethane showing all the covalent bonds. Draw a dot and cross diagram. Arun.
Okay, a molecule of ethane.
Yes. Draw it as a dot and cross diagram.
Miss, done.
Okay. Aram, have you sent it to me?
I am sending it.
Okay. I just got it. Right. This is fine. This is okay. Propanol can undergo reactions to form compound Y and compound Z. What happens to propanol when it forms compound Y? Propanol is what is propanol? What compound is propanol?
Alcohol.
Alcohol. So, and what is compound Y?
Um, Propane.
Yes, it's propene. So I'm taking my alcohol and I'm propanol and I'm turning to propene. What type of a reaction is this?
Miss, how is it propane?
This one, propene. What is the
Yeah.
general formula for propene? The general formula for propene is CnH2n. C3, 3 2s are 6. So
Okay.
this is propene. This is your alkene, propene.
H2N, CN, H2N, is there anything after that? Or just that's it?
Yeah,
Like
just
this
that
one?
CnH2n. That's it. That's the general formula of alkenes, right?
Okay.
CnH2n. So C3 and then 3 multiplied with 2 is 6. So C3 is.
Okay, Miss.
So what do you think we're doing over here? Are we doing addition, dehydration, hydration, oxidation?
Miss propanol is dehydrated.
Correct. Correct. If you remember, one of the reactions I had told you was that we can take an alkene and we can react it with steam, water in the form of steam, and we can make an alcohol. This is the opposite of it. So in that, I was adding water, and this I'm removing water. So we are
Okay, miss.
dehydrating. Compound Y can also be formed in the following reaction. So I take this compound X, C3H8, and I can use it to make compound Y and hydrogen gas. First of all, what type of a reaction am I doing? Okay, forget the type of reaction. Forget it. Look at this question. Explain how bromine water can be used to distinguish between compound X and compound Y.
Miss in compound X, in compound X, bromine water will not change color, means it will stay from orange to orange. And in compound Y, it will
Yeah,
change from orange to colorless because it's an
correct.
alkene.
Correct. Okay.
And compound X is an alkene.
Yes. Compound Z is a carboxylic acid. Which of the following shows the functional group of a carboxylic acid?
D.
D, are you sure? You want to look again?
No, wait, sorry. I'm bad. C. I didn't see the oxygen. C.
Yes, C is correct. Now, take a look at this. Compound Z is an acid and turns litmus and universal indicators papers red. Compound Z also shows other acidic properties. Devise an experiment that would show another acidic property of compound Z. To answer this, you can use your previous knowledge from acids and bases
Okay,
because
miss.
carboxylic acid is an acid. So all the things you've studied about acids, they apply. It applies over here.
Miss chemical or physical property?
Up to you. Up to you.
Miss, you can react it with a base and then test for water
How are you going to test water?
because neutralization reaction produces salt and water.
Uh, Wouldn't it be, yeah, fine, but then how will you test that water is there?
Yes,
I will
carbon.
take your same experiment, but I'll just reword it and make it reword it a bit. Same
Okay.
experiment. Add an alkali, perform a neutralization reaction, measure the final pH of the solution. It should be red. It should be 7, right? Because it will be neutralized.
Okay.
Instead of
Okay.
saying test for water, you test for neutralization, right? Add an indicator, wait for the color change, right? So you do that.
Okay.
You wait for it to perform a neutral solution. What other test can we do? We can add a metal. We can add a piece of metal like a magnesium ribbon. So what will happen?
Yes. It
The
will produce
magnesium,
hydrogen. It will
yes,
produce
hydrogen
hydrogen.
bubbles of hydrogen gas will be produced,
So we can
and you
test
can
for that.
even yeah, and you can even test for hydrogen gas. You can add a
Okay.
metal carbonate. What happens when I add a metal carbonate?
Carbon dioxide is produced. So
Carbon
you can
dioxide
test for
produced. So you
carbon
see
dioxide.
bubbles of gas, and then you can also test for the gas to make sure it's carbon dioxide. You
Yeah,
can also
by
add
the
metal
method.
oxide. What happens when we react metal oxide to it?
It produces oxygen.
No.
No, metal oxide.
Yeah.
Water, maybe.
Okay. Remember this, metal oxide is a basic oxide. Remember I told you metal oxides are basic oxides?
Yes.
Non-metal oxides are acidic oxide. So it will act like a base and it will end up forming a solution. So you can also use a metal oxide.
Okay.
The structure of one molecule for compound is shown in figure 10. The compound in figure 10 is an unsaturated hydrocarbon. State why the compound is defined as an unsaturated hydrocarbon. You have to talk both unsaturated and hydrocarbon.
Miss separate definitions, it means.
Yes, separate definitions.
Miss unsaturated basically means when you can add no more of a certain substance, like salt and water.
Unsaturated, yeah, you are
Unsaturated.
correct. That is what unsaturated is, but that's not how you define it. Say that it has a double bond
Okay.
between two carbon atoms. That's what.
Okay, okay. Yes, that's what like I thought they just asked like the general term of unsaturated. But
Unsaturated
like,
means
since
that
it's
there,
different.
yeah, unsaturated means that we have a double bond between the carbon atoms.
Okay.
That's
So hydrocarbon just basically an element or a compound containing carbon and hydrogen
yes, that's it. A compound that contains carbon and hydrogen only.
only.
That's provided with unlabeled samples of three liquids. The three liquids are known to be hexane, hexene, and butanoic acid. Aqueous solutions of carboxylic acids contain hydrogen ions and undergo reactions that are typical of acids with indicators and carbonates. So, butanoic acid will act as any normal acid. Describe in detail using the information given and your knowledge of the reaction of these liquids. Tests the student should carry out to identify each of the three liquids. This is a 6 mark question. Okay. I'm
Okay.
giving you 5 minutes. Take 6 minutes. Okay. 5, 6 minutes. Go ahead, type out your answer. You have to give detailed test for all three liquids
To identify them, right? That's it.
to identify them. Exactly.
Miss, I know about hexene that you can add bromine, water, and butanoic acid. You can do like a reaction with metals plus acid or carbonate, but I'm not sure about hexene.
Sorry, Iram, can you say it again? Your voice wasn't clear.
Okay, sorry, miss. I know the reaction of hexene that you can add bromine, water, and the
Yes,
reaction of butanoic
yes.
you can add hydrogen, I mean
Mm-hmm.
metal, or you can just do carbonate, but like I'm not sure about hexane.
Okay. First of all, so go like this. Okay, we have to identify. Let's start the test number one. I'm not going to use the test for hydrogen. I'll tell you why. I will not, add a salt to it. I will go ahead and do it like this. I will take all three solutions and I will add metal carbonate to all three solutions. In one of the solutions, bubbles of carbon dioxide gas will be produced, right? Bubbles of carbon dioxide
Yes.
gas will be
Then you can test
produced,
it by lime water.
which we can test with lime
Lime water.
water. This solution will be carboxylic acid, and then you're going to write down the equation. The equation is going to be butanoic acid, C4, one second, Alhamdulillah, COOH, C3, 3. So I will have 1, 2, 3, 4, 5, 6, 7. So 7 hydrogen. Okay. So this is how I like to write the formula while making my equations, just because it makes it easy for me. I will write down COOH and then I will take out the rest. So COOH, right? And then I have 4 carbons. I've already drawn 1 carbon, so I will write down C3. And I have 8 hydrogen, so I've already wrote down 1 hydrogen, so I will write down CH7. So 3C3H7 will react with, let's take magnesium carbonate. Magnesium carbonate, MgCO3, right? And what will I get? I will get C3H7COOMg plus CO2 plus H2O. Right? Making sense?
Yes.
I will have to put a 2 over here because magnesium has a charge of plus 2. So I will get a 2 over here. So I will have to add a 2 over here as well. And you can take a look at the rest of the balancing, if the rest of the balancing is correct or not. You can take a look at the rest of the balancing. Okay. After that, you are going to go ahead and steps. So that's step number 1, right? The solutions that do not react with the carbonate are either your hexene or hexane.
Mm-hmm. Okay.
Now react the solutions.
With bromine water.
Yeah, one second. Yeah, now add with the now react the solutions with bromine water, right? What are you going to see? You're going to see that the alkene is going to turn
One
from
colorless.
the
One
solution
sugar.
which has hexene in it will turn from orange to colorless. And the other solution will stay orange. And then you will write down the equation for it. That I have my hexene, right, which is C6H12, and I will react it with bromine to give me C6H12Br2. And finally, I'm going to say that the solution which did not react with bromine but also did not react with the metal carbonate must be hexane. So there is no test for hexane. We're going to rule it out by we're going to rule
Hexene
it
and
out.
butyric acid.
Yeah,
Okay.
we're going to rule it out. We're going to
Also
say that, okay,
butyric.
yeah, so the one that reacts with carbonate is going to be the acid. So I will separate the acid. The one that reacts with bromine is hexene. The one that doesn't react with anything is the hexane. So that's it. There's no specific test for hexane. So you will rule it out. Perform other tests, and whichever one is left at the end that does not react with anything, that's the answer. Okay?
Okay, yes.
Okay, Arham.